Welcome. This video is going to show you guys how to generate the numbers needed to produce the 5-number summary as well as create a box plot based on those numbers. The example that we're going to go through will be the same as in the Lecture 5 notes where we looked at the grams of fat in breakfast meals ordered at McDonald's. So as always, the first thing we need to do is get this data into JMP. You could manually enter it if you want. I'm going to go ahead and open it. I have it as L5 for Lecture 5, McDonald's breakfast fat. Go ahead and open the data file. The data file, as you see, it contains one variable labeled as fat, and then the rows correspond to the observations. So there are 22 observations, or maybe 22 meals that we had looked at. All right, first off, to generate the 5-number summary, this is the same way we generated the mean and the standard deviation in the previous video. You would go to Analyze, Distribution. You pick your variable. That goes in the Y where it says required, so go ahead and move that over there and then select OK. And as we saw before, it produces a histogram, it produces a box plot. The quantiles and the summary statistics are shown below. Alright, now remember that the 5-number summary consists of 5 numbers: the minimum value, the maximum value, the median, and the first and third quartiles. So as always with software, they give you a whole lot of extra information, things you're maybe not so concerned with, but you got to be able to read off what is important. So looking underneath the quantiles, we see that the minimum is 1, we see that the maximum is 56, the minimum, or the median, is 20, and then the first and third quartiles are 11 and 28.75. And remember, those correspond to the 75th percentile and the 25th percentile. All right, now as we discussed in our lecture, the third quartile was different than what we got when we manually did this problem by hand. That is not uncommon because we chose a specific algorithm as to how to find that. It's obvious that JMP did a slightly different algorithm. This isn't something we're going to be overly concerned with. However, it is something you should be aware of, that it may not produce the same result as what we got by hand. This isn't really a big deal. I think it's fine for us to trust the software and assume that the third quartile could be represented by 28.75. Alright, so anyway, the 5-number summary can be generated by going to Analyze, Distribution, and then reading the relevant numbers off of here. Now, we also want to be able to create a graph called a box plot based on the 5-number summary. There is actually a graph here shown, but with the histogram it's kind of cluttered, hard to look at. So what we're going to do is we're going to close this window out here, and we're going to generate a nice box plot by going to Graph, Graph Builder. Now, we used this before to create bar charts and pie charts, and we can do it for box plots. What you're going to do is drag your variable where you want it. So suppose, for instance, that you put it on the x-axis, puts a bunch of dots here. We need to tell the software what type of graph we want. Remember, the graphs are located along the top, and if you hover over any of them, it will tell you which is which. But this is the one we want. If you hover over it, it says box plot. And what this will do is it will display a horizontal box plot. Now, this is perfectly acceptable. However, a lot of the times, these are displayed vertically. So what we're going to do here, I'm going to go back under Graph Builder, select Start Over. That'll clear off my graph. And this time when I do it, I'm going to place that variable fat on the y-axis. Again, select the option for box plot. And now I have a vertical box plot. Okay, now a couple of things. Whenever we went through this in the class notes, we checked for outliers using this 1.5 times the interquartile range rule of thumb, and that's perfectly acceptable. The software will actually check for outliers for you, and what's going on here is rather than drawing this whisker, if you will, up to the maximum value, it cuts off here and you see a dot up here at the maximum value of 56. Now, one nice thing about using the graph builder is if you point at that dot, if you actually hover over top of the dot, it will tell you which observation in the data set that dot represents. So this tells me it's in row 14, fat value of 56 grams of fat. That is serving as our outlier. Okay, the second thing I want to reiterate from our notes is you can really use the shape of this box to determine what the shape of the distribution, whether it be symmetric, right skewed, left skewed, etc. So remember that the median is this line in the middle. The line at the top of the box is the third quartile, and the line at the bottom of the box is the first quartile. So in a symmetric distribution, the distance between the median and the third quartile should be about the same as the distance between the median and the first quartile, and that's what we see here. So we have evidence that this is a relatively symmetric distribution. All right, thank you very much.